Many program managers build their master schedule by simply copying 6 separate project plans into a single file. But pulling dates into one view is aggregation, not integration. True integration requires mathematically reconciling the underlying logic between every single task. Stacking these schedules creates an illusion of control. It makes a sprawling program look organized while actively burying the greatest risks. Look at the paste-together model on the left. Cross-project links are invisible. One vendor slipping blindsides the entire program. Now look at merge on the right. With shared logic and visible links, one slip forces the program to mathematically adapt within days. The cost of ignoring this difference is severe. 58% of program-level schedule slips trace back directly to undetected cross-project dependencies. A rolled-up schedule built from paste and hope isn't a unified plan at all. It is simply 6 separate, unmanaged risks wearing one file name. This aggregation habit creates a delay time bomb. A rolled-up schedule can sit on an executive dashboard, looking perfectly healthy, while failure quietly builds beneath the surface. Statistically, an aggregated master schedule will run for an average of 11 weeks before a hidden conflict finally surfaces. It takes almost 3 months for the truth to emerge, because the critical handoffs between different vendors exist only as tribal knowledge in someone's head, rather than as calculated data points in the system. 2 parallel project work streams can look perfectly fine in isolation, while mathematically heading toward an inevitable collision. The absolute baseline rule for schedule validity is strict. If a PMO cannot mathematically calculate a single unbroken critical path from their master schedule, the document is invalid. True program risk is almost never found inside the long, multi-month project phases. The fatal risk lives entirely in the unmapped seams between them. Program managers assume if individual owners track their own risks accurately, the overall program is secure. But individually accurate schedules can still derail a program. The first silent killer of integration is the calendar flaw. Region A executes their work on a standard 5-day week, while Region B operates on a 6-day schedule. When you roll these conflicting calendars into a single master view, every date breaks, creating a compounding mathematical lie. The second silent killer is the lack of a shared work breakdown structure standard. If you do not enforce a unified WBS and strict milestone naming conventions, no 2 subschedules can be reliably compared, let alone merged. Programs that allow vendors to use different calendars and coding structures experience 4.2 times more emergency rebaselining events. Coding standards and unified calendars are not administrative PMO overhead. They are the rigid mathematical prerequisites required to calculate a trustworthy program date. To see how these administrative flaws trigger real-world crises, look at the Helios Grid modernization program. The setup involved 3 regional utility vendors. Each vendor ran highly detailed substation upgrade schedules, but they used different tools, different working calendars, and different activity coding. Every month, the program office committed a fatal error. They simply copied the rows from all 3 vendors into one master file, calling it unified. A critical project delay suddenly surfaced a mere 2 weeks before a massive, highly public program commissioning date. The root cause was a 2-week permitting delay in Region B, which was entirely dependent on a specific cabling milestone finishing in Region A. The software missed the conflict because nobody had coded the dependency as a cross-project link. That vital connection only existed in one engineer's head. The Helios program did not fail because of a poor construction pace. It failed because the PMO relied on aggregation instead of building a mathematical digital bridge between their vendors. You cannot fix an integration failure by scheduling more status meetings to discover missing links. The solution is fixing the schedule's underlying architecture once. This requires a mathematical first principles approach to schedule architecture, known as the MERG framework. In the establish and map phases, the PMO forced all regions onto one shared calendar. They took the invisible connection between Region A's cabling and Region B's permitting, explicitly coding it as a visible dependency. This elevates the single program-level critical path. The newly elevated path proved that Region B's permitting, a short, seemingly minor administrative task, was actually driving the entire multi-million-dollar commissioning date. The true driver of a massive program is rarely the longest individual project. It is only found by calculating the hidden connections between projects at the program level. Structurally fixing the Helios program delivered immediate results. The average time that was required to catch a new cross-region risk dropped from 11 weeks down to just 9 days. This checklist outlines the ultimate requirement. True integration isn't a master file rebuilt monthly from scratch, it's a permanent structure. Under the govern principle, because everything is explicitly linked, one vendor's local change can instantly invalidate a milestone 3 teams away. Therefore, any schedule change that touches a cross-project link must route through a singular program-level change control gate before it is accepted into the architecture. Can you calculate one unified critical path, or are you just staring at 5 Gantt charts sharing a tab? Most massive programs do not fail from bad individual projects. They fail because leadership neglected to mathematically govern the seams between them.